Okay, screencast number 3, marginals are magnets to averages. Now this screencast isn't so much an economic screencast as it is a mathematical screencast. You might like that or not. But we're going to be talking about a mathematical concept here that's going to explain a lot of what we're going to be doing going forward, and it serves a great deal to explain why those curves that you see that we haven't got to yet look the way that they do. Alright, so in the last screencast we left with this graph of total product, marginal product, and average product. And I pointed out that there's something special that's happening where marginal product and average product are crossing. Specifically, that average product peaks out at exactly that point. In this screencast, I'm going to try to explain why that is. So in the last screencast, again, we were looking at total product, marginal product, and average product. And there's something that you need to know about marginals and averages. Marginals, it turns out, act like magnets to averages. Now in this screencast I'm going to be talking about marginal product and average product, but I want you to know that this applies to every marginal and average. So in the future you're going to hear other terms like marginal revenue or marginal cost. And anytime you hear one of those terms, I want you to know that the marginal is going to act like a magnet to the average. So marginal revenue is going to act like a magnet to average revenue. Marginal cost is going to act like a magnet to average cost. Marginal product is going to act like a magnet to average product. And what I mean by magnet, and I'm using that as a metaphor, is that marginal numbers pull average numbers in their direction. So to understand what I'm talking about, let's take a couple of simple examples. Let's say you have an 80 average in this class. And on your next, or marginal, right, that's what marginal means, additional or change. On your next exam, your marginal exam, you get a 90. What has to happen to your average? Or, let's say that last week I was biking, and I was averaging 17 miles an hour for the first 20 miles that I rode. And let's say that on the next mile, that marginal mile, I biked at 14 miles an hour. What has to happen to my average? Well, it's kind of intuitive. In the exam or the class average example, if you have an 80 average and you get a 90 on your next test, your average has to go up. That marginal number, the 90, is pulling the average number, the 80, in its direction. Or in the biking example, if I'm biking at 17 miles an hour and then the next mile I bike at 14 miles an hour, my average is going to have to drop. Again, that marginal is pulling the average in its direction. Excuse me. So as long as a marginal number is above an average number, that average number has to rise, even if the marginal number itself is falling. I'll explain that in a second. Or as long as the marginal number is below the average number has to fall, even if the marginal number is rising. Gave you a little example in the bottom of the screen. Let's say you take 4 tests. On the first test you get an 80, so you have an average of 80. On your next test, your marginal test, that second test, you get 100. Your average is obviously going to rise. Your marginal is pulling your average, which was an 80, up. Now your average is a 90. Let's say on your third exam, you get a 95. Now here, your marginal, 95, is higher than what your average was, which was a 90. So the 90 average has to rise. Notice that your average is rising, even though the marginal is falling. The marginal is falling from 100 to 95, but that 95 is still higher than your average, and so your average had to rise. If on the fourth exam you got a score of 93, that 93 is still above what your average was before that exam, which was a 91.7. So again, even though the marginal number is still falling from what it was, your average again has to rise. Marginals act like magnets to averages. So let's look back at Tina's Pillow Pet Factory and let's see if we can see that magnet action at work. We'll pick out a couple of workers here just to show you what's going on. Take a look at the second worker, and specifically take a look at the marginal product of the second worker. The marginal product was 10. Now compare that excuse me, to what the average was before hiring that worker. Before the second worker, we had an average product of 5. Since the marginal product of the second worker was 10, and that marginal was above the average, since 10 is greater than 5, the average had to rise. that marginal product of 10 is raising the average from 5 to 7.5. Or take a look at another worker, the fifth worker. And specifically, again, look at the marginal product of that fifth worker, which is 5. Notice that the average before that worker was 10. The fifth worker's marginal product is below that average, and so that average has to fall. In this case, it's going to fall to 9. Marginals act like magnets to averages. They pull them. So if that next worker has a marginal product that's greater than the average will rise. If the next worker has a marginal product that's lower than the average will fall. So now let's apply that graphically. We're going to focus on the two graphs we were looking at last time, but again, now I want you to focus solely on that bottom graph and see if you can see that magnet action at work. Notice that as long as the green line, the marginal line, is above the average, the orange line in this example, the average curve has to rise. That's happening all the way here, from here to all the way over here. Notice that for all those quantities, the green line is above the orange line, and notice what's happening to the orange line. The orange line is rising. It's kind of like that green line is pulling that orange line up because the marginal is acting like a magnet to that average. Now once the marginal curve dips below the average curve begins to fall. From right here all the way to here, the marginal product numbers are below the average. And notice what's happening to that orange line. That orange line is starting to fall. Again, that green line is pulling that orange line down. As a result of that, and this is the upshot of all this, the marginal product curve has to intersect the average product curve at the very maximum of that curve. Because as long as the marginal product curve is above it, it's rising, the orange line is still rising, orange line is still rising, until they meet. And as soon as they meet, and thereafterwards, the marginal product curve is underneath the orange line, and it's pulling it down, down, down. As a result of that, average product has to peak out where the two curves intersect. Excuse me again. So we're going to see the same kind of action going on anytime we see marginal and average whatever. That marginal is going to be pulling the average in its direction. And that's going to be important going forward, especially in the next screencast.
Oh no! Oh no! Oh no!
Oh yeah!